Section 1.1 and 1.2. These two sections deal mainly with key terms of geometry, so we're mostly going to be looking at definitions. So the first term that we want to identify is the term equidistant. And equidistant means literally equally distant, or in other words, the same distance. Number 2 is point. Now, a point is represented, by a dot. Okay. The key idea is a point has no size. Okay. And we name a point with a capital letter. So if I have this point, I might name it point A, or this point might be point D. Okay? And a point is the smallest part of any geometric figure. So in other words, all geometric figures consist of points. Okay, and so in other words, points are the building blocks. Just like in science, atoms are the building blocks, while in geometry, points are the building blocks. Number 3, we have the idea of a line. Okay, a line extends in 2 directions. Okay, without ending. In other words, it goes on forever and ever. A key idea is it has no thickness. Okay. Because a line is made up of infinite points and a point has no size, then a line has no thickness. Also, a line cannot be measured because it goes on forever and ever. We name a line by either a lowercase letter So for instance, I might have this line and call it line L, okay? Or we name it by 2 points on the line. So for instance, I could have this line and I could identify this is point A, this is point B, and so we would call this line AB. The symbol we use in order to not have to write out the word line is a miniature line over the 2 points that name it, so line AB. We could also call this line BA. Okay? And the fourth term is plane. Okay. The idea of a plane is that it's a flat surface that goes on and on forever. Goes on and on forever. So we say it's suggested by a floor. So the floor in our classroom is part of a plane, a flat surface that goes on forever. Or a wall is part of a plane. A tabletop is again part of a plane, okay? However, remember a plane extends forever in all directions without stopping. So without end. And a plane has no thickness. It also has no edges. So it has no edges. So even though it's suggested by a floor, a wall, or a table, all of those have edges, but an actual plane has no edges, and that's a key idea. It has no edges, but we often represent it with a four-sided figure. So we would represent it with this, and we can name it again by a capital letter. So we could call this plane P, or we can, and this is a key idea, put a star in this one. At least 3 non-collinear points. Okay. Non-collinear means that we cannot, without lifting our pencil, draw a straight line. So if I have point A, B, and C, all of those are on a straight line. So those are collinear. They're all on a straight line. But if I have D, E, and F, there's no way to draw one single line through all three of those points. So we can name this plane EDF. Okay? So we can either name it by a capital letter or by 3 points that are in what we say in the plane or belong to part of the plane. Okay. Key point. Okay. The terms point, line, and plane. This is very important. It will be on a test. Point, line, and plane are what we call the 3 undefined terms of geometry. Okay, and again, this will be on a test, so you want to make sure that you understand that point, line, and plane are the 3 undefined terms. Okay, the next thing we have is the idea of space. Space is 3-dimensional, and it's defined as the set of all points. Okay. Then we have what are called collinear. And we talked about those earlier when we talked about how to name a plane. Collinear means that all the points are on the same line. Okay, so if I have this line, I would say point A, B, C, and D are all collinear because they are all on the line, okay? But if I have a point E down here, then A, B, C, D, and E are not collinear because E does not belong on that line. However, I could draw a line through A and E, and so A and E would be collinear points. Then, as I said before, we have the idea of non-collinear points, and those are points not on the same line. Then we have what we call coplanar points, and those are points all in the same plane. And non-coplanar points are points that are not all on the same plane. Okay, so if I have this plane, and then, which I'm trying to represent as a horizontal plane, and then I have this plane, which is a vertical plane, okay? So if I have a point A here and a point B here, those are non-coplanar points. But if I have a point C here, A and C are coplanar because they belong on that vertical plane. B and E are coplanar because they both are in the plane that is horizontal. And if I have a point X right here, well, X belongs to both of the planes. So X is coplanar with E and B, and it's also coplanar with A and C. Okay. And then we have the idea of intersection. Intersection is where if two figures meet, then the set of all points belonging to both figures is the intersection. Okay, so for instance, if I have line L and line N, they intersect at this point. We're going to call that point X. Okay, so if two lines intersect, they intersect at a point. So X is the intersection of those two lines. Okay, up here on our planes that intersected here, okay, if two planes intersect, they intersect in a line. And so this line belongs in both planes. So we say it is the intersection of those points.